In this demo, I'm going to present the key features developed in the NGI ONTOCHAIN Babelfish project. It covers the full workflow of sharing data through a data intermediation service and demonstrates data exchange between a beekeeper as data provider and a digital product passport service as data user. First, we are going to establish identities for each stakeholder, and we need to register the entities in the Gateway API. We create identities for the beekeeper, the data intermediary, and the intermediary. Next, we are going to establish an organization for the data intermediary, registering the organization on the Gateway API, retrieve the credentials of the admin user, and using those credentials to get the necessary token for this organization. Using this token, we can now create the respective users, one for the beekeeper and one for the intermediary. With the basic definitions set up, we will now define the first data agreement between beekeeper and intermediary. We start by creating a domain-specific data agreement, a D2A, and fill out a SOA form. We load the D2A structure and enter some data. We see here a green claim for seasonality of agricultural products, and it consists of a number of machine-readable attributes and some free text fields. We take the JSON and write it into a file. To create a verifiable credential from the data agreement, we need the signatures from the beekeeper and the data intermediary. Next, we create the verifiable credential with the following statement. What's going on here? We take the initial data agreement and adding the two signatures from beekeeper and intermediary to compile the verifiable credential structure. We create the verifiable credential with the issuer being the beekeeper and the holder being the intermediary. Accessing a verifiable credential which is not public requires the credentials from the holder, and we are going to use this information to compile a verifiable presentation. The first part reads the existing verifiable credential, and here we create a verifiable presentation, signing it with the key from the holder. The presentation is now available publicly under this location. We have now entities and data agreement set up, and the next step is to configure the intermediary to hold data for our data exchange. First, we need to retrieve a token to access the Gateway API. Then we provide the necessary information to set up a collection. We provide a name. We specify metadata to be persisted on a distributed ledger. And we also register the verifiable presentation that we just created as a contract for the data to be shared. We can retrieve data for the collection and show the metadata. Now we have everything in place to make the actual data transfer from the beekeeper as data source to the data intermediary. We use again a SOA form to generate the data to be exchanged. We see here the identity of the beekeeper, date of production and quantity. We have an image of the migration data of bees, the location as civic address and as latitude longitude. We copy the resulting JSON object and store it in a local file. To write the honey data into the collection as the intermediary, we need to first create the metadata object and can then upload the actual data. This is a metadata object and this is a data upload. Let's now check the uploaded information. We read the object and get here the DRI, the fingerprint of the payload. And this is a transaction hash of the record stored on the blockchain. We can use the Babelfish blockchain explorer to look at the recently created transaction and see here also the fingerprint of the payload. With data now available in the intermediary, we are going next to establish a relationship with the data user to disclose the data. For this, we are using a domain-specific data disclosure agreement, or short D3A. We have here an already filled out data agreement for the intermediary, and it holds again a number of machine-readable properties and some free text fields. The first question we need to address now is if the D3A from the intermediary is compliant with the D2A provided by the beekeeper. To evaluate this, we extract the machine-readable properties from the respective data agreements and can show the content of such usage policies. Now we validate the compliance with a reasoner developed for this purpose. The status code of 200 confirms the compliance. Since we have now a valid D3A, we can execute again the process of signing the data agreement, this time by the intermediary and the intermediary. Finally, we create the verifiable credential as proof of the governance for the data disclosure. In the final step, the intermediary can create now the digital product passport with the information provided by the beekeeper. The intermediary retrieves the token to access the data at the intermediary and can now read the data and create a digital product passport, shown here. The information is made available on a public service endpoint, and we create a DID as a decentralized access point. The resulting identifier can now be shown as a QR code on the product, and consumers can resolve it and access the underlying information with their smartphone. This concludes the end-to-end process of exchanging data in a short supply chain. Of course, we have to acknowledge that a number of simplifications have been applied for brevity, like managing credentials, secure data transfer of signatures between parties, and specifically, one has to be aware that this demo was purely about technical aspects of the underlying building blocks. In a concrete use case, it would be necessary to integrate the various pieces and automate the process that were now shown on the command line. To also provide a high-level perspective of this use case, this video ends now with a customer-centric demonstration of the topic. Many of us ask ourselves, how can we make so-called green claims comprehensible for consumers? Our example, honey directly from Vienna. The beekeeper records the location of the bees, and the seasonality of the honey can be determined by the Vienna tree register and the time of data collection. This creates a green claim about the type of honey. The information is then coordinated by Data Intermediation Service, developed as part of the NGI ONTOCHAIN funded project Babelfish. The green claims are made traceable and are effectively substantiated through decentralized identifiers and verifiable credentials. And how does this information get to the consumer? A consumer simply scans the QR code on the label and thus receives secured and verified information about the product. Transparency, traceability, and trust, the future of product differentiation.